Hello everyone, my name is Abhishek and welcome back to my channel. Okay, so today I'm here with the ultimate CI/CD pipeline. So last couple of days, or from last couple of videos actually. So I have been getting this continuous request where people are asking me about Abhishek, can you explain me about a real-time CI/CD project, or can we do a real-time CI/CD project on the channel? So I thought, okay, I'll just take some time and I'll explain you the ultimate CI/CD pipeline where I'll cover all the tools. And trust me, if you will be able to explain this setup as is in your interviews, then your interviewer will be really impressed, because these are the tools that are currently contemporary. These are the tools that are ruling the CI/CD. So I used Jenkins, which is a top CI/CD tool. Then I used Argo CD. I'll also talk about the image updater, how to create a Docker image, all of the things, SonarQube, Maven. So this will cover the end-to-end CI/CD project. And try to follow this video. If at all you are not able to follow, let's say you are not able to understand at any point of time, so what you can do is you can go back, and you people know that I have a GitHub repository for Jenkins where we used in our 45 days of DevOps learning as well. So this repository is called Jenkins Zero to Hero. So in this repository I have put together all the points, like it will cover each and every details. What are the plugins you need to install in Jenkins? How do you set up each and every tool? How one tool is communicating with the other tool? And step-by-step approach, right? So you can also refer to the diagram. Let's say in the video you're not able to follow it. By reading through the steps, you can refer the diagram and you can understand completely. So don't forget to star this repository and fork this repository. If you star the repository, you will get the future updates as well. But if you just fork it, you will not come to know the future videos, or if I in future, if I update some content here, fork will not notify you. Okay, now going back to the discussion. So everybody was asking about it, so I thought I'll make a video. But this cannot be done in one single video, because this is a very lengthy discussion, because I have to cover each and every tool in detail, because many people might not understand what is GitOps. Many people might not understand what is SonarQube. So I decided that I will explain this in a very detailed way in two parts. In the first part today, I'll explain you how to answer the question if your interviewer is asking what is your real-time CI/CD project in your organization. So I'm going to explain you how to answer this question with respect to tools, how each tool is communicating with the other one, and what is your entire setup, what is the notification process, what happens if things go south. All of the things are very detailedly explained in today's video. And tomorrow's video, again, you can follow the same GitHub repository and you can see the live Jenkins file, or just addition to today's video. But don't forget to watch the video till the end, because if you're not watching the video till the end, then in tomorrow's video, or even during your interviews, you will miss some major points where interviewer will understand that, okay, you haven't implemented this in real time. Perfect. And the very important aspect of this video here is not everything is done through the Jenkins pipeline, because we are using the GitOps approach, and GitOps approach is a modern way of doing continuous delivery, declarative continuous delivery model. So I've used Argo CD, but you can also replace it with Flux, or you can also replace it with Spinnaker. But Argo CD is the most used. So let's go with it and let us try to understand the process. So firstly, one thing that you have to notice is there are two Git repositories, right? So this is a Git repository for the source code, and this is the Git repository for the manifest. Now, what is the meaning of it? Why there are two Git repositories, and why your Jenkins pipeline? So if you see here, everything is flowing through the Jenkins pipeline till here, but from here, it's a pull mechanism. So your Jenkins pipeline has ended here. So your Jenkins pipeline is only doing the continuous integration. Okay. So this part of it is just for the continuous integration, and this part of it is for the continuous delivery, and there are no links attached. Like your Jenkins pipeline is no way triggering your how do I say it, your CD process. Then how is your CD process getting notified about your CI process getting done? So all of this information will be very interesting. And again, what I want to say before I jump into drawing the diagram and explaining you, watch the video till the end. Only then you will be able to understand the each and every aspect of this video. Okay, so now without wasting any time, let us try to understand this diagram on the other terminal that I have, where I can write and explain you. Okay, so meanwhile, you people can go here, start the GitHub repository, and you people can also start reading it. after the video is done. Okay, so quickly let me stop sharing this one here. Where is this? Yep, stop share. Perfect. Now let me start sharing on the other terminal that I have. Perfect. So parallelly, you people can open the GitHub repository, right? You can find the link in the description so that you people can see the diagram and I can explain the diagram in parallel. Okay. So that way you will be able to understand it in a much better way. First of all, what is CI/CD? I have explained all of these things in a, in our 45 days of free DevOps course, but in a very nutshell, or in couple of lines, CI is basically continuous integration and CD is nothing but your continuous delivery. So CI ensures that your build is smooth, all your tests are executed, your code quality is maintained, and your image is created. All of these things falls into your CI process. Whereas CD is continuous delivery, which ensures that your deployment or your delivery process is done. So in our case, we will use Kubernetes because Kubernetes is the most used deployment platform these days, right? Every application is containerized and they are deployed as pods or deployments. Okay, so first of all, we will have a Git repository, right? So I think this is something that everybody understands, that you have a Git repository. Let's say we are talking about Java code, right? So what happens is usually the developer store the Java code in the Git repository, right? And there is Jenkins or any other orchestrator which is responsible for watching the commits onto this repository, or which is responsible for watching the pull requests onto this repository, right? Whenever there is a pull request created, your Jenkins pipeline has to be triggered. So let's say there is a developer who has committed a change to this Git repository. Now, how does your Jenkins get notified? So this is your interview question number one. So there are multiple ways how your Jenkins pipeline can be triggered, right? But what is the most efficient way is to use webhook. So whenever you are using the webhook, what happens is instead of Jenkins watching your repository, okay, Jenkins will not watch your repository, but what happens is your Git will send the notification to your Jenkins. Okay, so how do you configure this webhook? Basically, you can go to the Jenkins and you can get the webhook URL. You can take this webhook URL and you can put that in your GitHub settings. Okay, in your GitHub settings, you will have an option for webhooks where you can define for which action the webhook has to be triggered. So you can say it has to be triggered on commit. You can say it has to be triggered on pull request. You can say it has to be triggered on issue. So all of these things can be controlled in the GitHub settings page. We have also discussed this in the 45 days of DevOps course. So as you configure this, whenever developer has created a pull request or whenever developer creates a pull request, your your Git will send a notification to Jenkins and ask Jenkins to trigger the pipeline. Okay, so now Jenkins starts triggering the pipeline, and this is where the DevOps engineer roles comes into play, right? For example, if you're managing the Jenkins installation, configuring of all of the plugins and all of the things, yeah, that is still fine. Let's say you are not responsible for all of these things. Okay, so what you would do is you would write a Jenkins file, right? So using your Jenkins file, what you will do is you will try to perform a set of actions using your Jenkins files on your Jenkins. Okay, what are that set of actions? One is firstly you will use Maven because we are talking about the Java application. So you will use Maven, and what you will do using Maven is you will try to build the application. So again, all of these steps are very clearly mentioned in the GitHub, how to install or how to configure the Maven plugin and all of these things. So how do you configure this Maven plugin? Basically, you go to your Jenkins, you go to your configure system and you install Maven. Or the other thing that you can do, which we learned as part of our 45 days DevOps course, is for each of these stages, what you can do is you can use a Docker agent, right? When you use a Docker agent, you don't have to worry about the installations at all. right? I've shown you that as part of our 45 days of DevOps course. If you haven't watched those videos, you can watch the video using the link in the description. So if you use the Docker agent, you can skip the installations, you can skip the configurations, because Docker images are directly available for these things. Now, let's say you have built. As part of your build, what happens? Unit tests will be run, right? So once your unit tests are successful, you can perform some static code analysis. Okay, let's say both your unit test and static code analysis is successful, then only then you will move to the next stage. So what happens if your build stage goes south, or what happens if your build stage fails? So in such cases, what you can do is you can configure some alerts, or in Jenkins there is something called as email plugin, or you can send out email notifications, or you can also send out Slack notifications using the APIs, or any other notifications. Let's say you're on AWS, you can send out AWS email notifications. So if the build goes south, or if the build fails, then you can send out email notifications. If the build passes, right, if it is a success, then you can move to the next stage. As part of the next stage, what you can do is you can integrate it with SonarQube, or any other you know uh, code scanning tools, or the security scanning tools, and you can verify what happened in your previous stage. Or let's say your build was successful, but you can verify here saying that, okay, did it reach a specific threshold of our organization? That means to say, is it matching with the compliance of our organization? Does it have errors less than X percentage, or are there any security vulnerabilities inside the code that is written by the developer in the pull request? If there is any security vulnerability, I mean, what is a security vulnerability? Your code is not looking right in terms of security. So in such cases, again, if it is a yes, that there is a security vulnerability, you can send out mail notification. If there is no security vulnerability, that means no. So what you can do is you can proceed with the creation of Docker image. Okay, so as you proceed with the creation of Docker image, right? So what you will do is you can probably again use a Docker agent itself, or you can basically create a Docker plugin here, or you can write a shell script. As part of the shell script, you can run the commands, like you can just say Docker build, Docker run, right? So what I'll do is I'll just say Docker build. Okay, and using the Docker build, you will get a Docker image. So what you will do as part of the pipeline is you will send this Docker image, okay, to a Docker registry, or you will send it to a container registry. So this container registry can be anything, like it can be a Docker hub, it can be quay.io, it can be ECR, right? Elastic Container Registry, or it can be anything, whatever your organization is using. So till now, are the steps clear? So all of these things is nothing but the continuous integration process. Okay, so everything that we have discussed till now is about continuous integration. So what we have done in the continuous integration? Firstly, we started with a developer raising a pull request, or he's trying to push something to the Git repository, and here the Git can talk to Jenkins, because Jenkins is your CI tool, or Jenkins is your orchestrator. So Git can talk to Jenkins in multiple ways. One is Jenkins can continuously poll this one, right? The other thing is you can configure some build triggers in Jenkins, but the most efficient way is to use webhooks. So this is one of your interview questions as well, because if you are polling continuously, or if you are doing some periodic build triggers, the problem is that Jenkins will continuously try to send requests to your Git and try to fetch the information. So you are making a lot of API calls to your Git. Whereas if you are using webhooks, what webhook does is it only sends notification, or it only sends a trigger to your Jenkins whenever the webhook is triggered. And when does the webhook get triggered? Only when a specific action is performed on the Git that you are expecting. So let's say you want to trigger on pull request. So Git will say Jenkins that, okay, someone has raised a pull request to me. Why don't you trigger a Jenkins pipeline? So Jenkins, as it gets notified, it will start with the Jenkins file, or it will start with the Jenkins pipeline. And inside this Jenkins file, you can take a look at Jenkins file sample in the same repository, the Jenkins 0 to hero. What you will do is the most efficient way. Again, your interviewer will ask you, what type of Jenkins file are you following, or what agent are you using in your Jenkins file. So always go with the declarative Jenkins files, because declarative Jenkins files are better. Whereas in terms of scripted pipelines, it is more of unstructured way scripted pipelines. And if you have a strong development team that are writing Jenkins files, in such cases only go with the scripted pipelines. Whereas declarative pipelines are very easy to write, very easy to collaborate, and even if someone does not have a proper technical knowledge, they cannot write Groovy scripting a lot, or they are not very experienced with the programming. So in such cases, declarative pipelines are better. So this is one question. And the other question would be, what type of agents are you using in your Jenkins? So to answer this question, you can basically say that we are using Docker agent, which is very light in weight and which is very useful, because if you're using Docker agents, you don't have to do a lot of installations. For example, you don't have to install Maven. You don't have to, if you're using any testing tools, or if you're using Python or Java to test something, you're building your uh, uh, Java application, so you don't have to install Java. So in such cases, go with the Docker agent. And what happens is your Jenkins file will start with the Maven. It will trigger the Maven, and then it will trigger the SonarQube or whatever you use for the SAST or DAST testing. And then you can perform some other testings using your functional tools, regression tools, Selenium, UFT, whatever it is. And finally, if everything is passing, then you will create a Docker image, right? And you will push the Docker image to your Docker registry. It can be ECR, it can be Docker Hub, or it can be Quay.io or anything. So all of this has been your continuous integration process, right? Everything that we discussed till now is continuous integration process. And at the end of the continuous integration, what happened is you have an image ready. This image has new tag for sure, right? Because previously, let's say your image was version 1. Let's say you have an image with version 1.0.0. Okay, for example is your name of your application. You'll say example colon v1.o.o. So this will be your previous artifact, whereas your new artifact will be something like example app colon v1.0.1, because you are trying to change something, right? So now you will try to push this example app v1.0.1 to your Docker container registry. This will be your last stage of your continuous integration. Now, once this is pushed, how does your CD get triggered? Okay, so this is the most important point. People are very strong in the continuous integration, but people fail to answer about continuous delivery. Okay, so how does CI and CD communicate with each other? Okay, so traditionally what people were doing is people used to are very used to use Ansible playbooks, or people use some shell scripts. Okay, and they include the CD also in the same CI pipeline. So once the image is built, what they usually do is they trigger the Ansible playbook, or they trigger the shell scripts, which will push or deploy the artifacts to Kubernetes or any of your target platform. But the problem with this is that, you know this is not much scalable. And also the other problem would be, like, your Ansible or shell, all of these things, they are not designed for the continuous delivery, right? So for that reason, what you need to do is you have to choose a continuous delivery tool. And the best continuous delivery tools in the market right now are the GitOps based tools. Okay, why am I saying that the GitOps based tools are the best tools in the market for continuous delivery? Is because what GitOps says, or what GitOps practices, is similar to your source code. You should also create a Git repository. Okay, similar to your source code, you should create a Git repository, and this Git repository will have your application manifest. What are application manifest? They are nothing but your Kubernetes pod.yaml or deployment.yaml, service.yaml, for example. Okay, so these are the application YAML manifest that you have in your Git repository. Now, why you need to put these things in your Git repository? Why can't you simply create these things in your CI pipeline? That is because you don't have a proper mechanism. If you're doing that, let's say uh, tomorrow, okay, you just want to, instead of updating the version of your pod.yaml application or your deployment.yaml of the application. Let's say you just want to add something, like you want to add a new volume to your pod, or let's say you want to create a new mount point. So in such cases, your CI will not come handy, because your CI is basically triggered whenever there is a change in the source code. But here, what the DevOps engineer has done is he has added a new volume to the pod. Now, how do you do that? So in such cases, if you are not using a proper GitOps tool, if you are not using Git as a source of truth for your application manifest, then the DevOps engineer should directly log into the Kubernetes cluster, and he has to directly update the Kubernetes cluster pod.yaml. So what happens in this case is there is no verification. Nobody is verifying this, or there is no auditing. There is no code review. So for that reasons, you should use Git repository, not just for the source code, but also for your application manifest, right? So, but the question remains same. Now you have created a new image version in your CI pipeline. How will your Argo CD or your GitOps tool come to know that, okay, there is a new image in the CI? So my pod.yaml or my Helm chart, whatever it is, okay, how will they come to know that my the Helm chart should be updated with the new version that was created by the CI pipeline? Pod.yaml should be updated with the new version that was created in the CI. So for that, you can do two ways. One is there is a very good tool called Argo Image Updater. So what Argo Image Updater does is it will continuously monitor the Docker Hub or any of your container registries, and whenever a new image version is pushed to your container image registry, Argo Image Updater will notify this Git. It will directly update this Git repository. Sorry for this. So Argo Image Updater will directly update the Git repository with the new version in the pod.yaml, deploy.yaml, or wherever it is required. If it is a Helm chart, it has capability of updating the Helm chart as well. Okay. Now, so the Argo Image Updater, step 1, it is monitoring the container registry. Step 2, it is updating the GitHub repository. Then there is Argo CD, which is continuously watching this Git repository. Okay. And it says that whenever there is a change in the Git repository, take the new pod.yaml or take the new deployment.yaml or take the new Helm chart and deploy to the Kubernetes cluster. Okay, so this is the process. So if you are confused, don't worry, I'll explain it one more time. So the CD process is very simple. So all of you might know about the CI process, but the CD process is very simple. As soon as your CI process is completed and a new image version is updated to your container registry, then there is something called as Argo Image Updater, or you can also use shell scripts here. But again, you should always go with standard, or you should always go with the tools that are that you can trust. Or you can also use GitHub Actions or any of the things. You can write one more Jenkins pipeline where you can just say that, push the new image manifest to Git. But the better tool to use here is Argo Image Updater. What Argo Image Updater can do is it can monitor the CI. Okay, so sorry, it can monitor the container registry, and whenever there is a new image in the container registry, it will simply go to the Git repository. This is application manifest Git repository where you have your pod.yaml, deploy.yaml, and Helm charts. So Argo Image Updater has updated your Helm chart values.yaml with the new image tag, or it has updated your deployment.yaml with the new image tag, and there is a new commit that is created in this Git repository by your Argo Image Updater. Now, as soon as this commit is created, what is the advantage of GitOps tools? So GitOps tools, which are Kubernetes controllers, which are basically sitting inside your Kubernetes cluster. Okay, so this is your Kubernetes cluster. Argo CD, which is sitting inside the Kubernetes cluster, which is a Kubernetes controller, what it does is it always tries to maintain a state between your Git repository and your Kubernetes cluster. That means whenever there is a new image, or whenever there is a volume, or whenever there is a mount, anything that you change for these resources, Argo CD is capable of picking those changes and deploying to your Kubernetes cluster. Okay, that is the advantage of GitOps tools. One is GitOps tools can pick the new changes. It can be any change. It can pick from the Git repository a new addition to the node, a new addition to your admission controllers, anything. It can pick from the Git repository and it can deploy onto the Kubernetes cluster. Not only that, if someone tries to modify this Kubernetes cluster, Like in the previous case, where you don't have a robust CD process, where you don't have GitOps process, whenever there is a change to the pod YAML file with the mount point, like I told you, developer would log into the, or DevOps engineer would log into the Kubernetes cluster, and he would update the pod.yaml. Now, if you try to do that with this robust CD process, Argo CD will say that no, I see in Git that this is not the right configuration for your Kubernetes cluster. So let me override this change. Whatever the developer has created, Argo CD will override. So this is how you set up the continuous integration and continuous delivery. So if you have to draw the entire thing in one diagram, and if you have to explain this entire thing to your interviewer, what you will say is, okay, so we have a setup. So I'm explaining to the interviewer. You will say that we have a Git repository where we have our application source code. Let's say I'm talking about a Java application. Now, as soon as a developer raises a pull request to this Git repository, we have configured webhooks. Using the webhooks, we trigger the Jenkins pipelines. So what we have done is we have used declarative Jenkins pipelines, because declarative pipelines are easy pipelines to write and collaborate. And as part of this declarative Jenkins pipeline, we run multiple stages. So some of these stages are, the first stage would be the build stage. Using the build stage, using Maven as our build language, what we do is we build the application. And if the build stage is successful, or if the application is built successfully, where we also execute some unit tests, the next stage would be we will perform some static code analysis. Okay, and using the static code analysis, we will verify that this application is not exposed to any static code. And after that, we also have some SAST and dash tools where we verify the application security. If this new change that the developer is writing introduces any security vulnerability, if any of these things fail, then we would send email notification, or we would send Slack notifications that we have configured. Let's say all of these stages are successfully done, then we would go forward and we would create a Docker image. So we are running simple shell targets to create the Docker image out of the Docker file, which we have stored in the Git repository itself. And as soon as the Docker image is created, again using the shell commands, we push this Docker image to the container registry. Let's say you're on AWS, you can say we push to the ECR. Let's say you are using a secure container registry like Quay.io. You can say that we use Quay.io, or you can say we use Docker Hub. Now this is our CI process. So for CI process, we are using Jenkins. And coming to the CD process, once the Docker image is pushed to the Elastic Container Registry or Quay.io, we have a Kubernetes cluster. Inside the Kubernetes cluster, we have deployed two continuous delivery tools. One is the image updater. Let me call this as IA, Argo CD image updater. Sorry, Argo image updater. And the other tool that we have is Argo CD. So both of these things are Kubernetes controllers that we have deployed on our Kubernetes cluster. What they do is, the first tool, that is Argo image updater, it would continuously monitor the image registry. And as soon as a new image is created, it will pick the new image and it will update the new image in another Git repository that we have. And this Git repository is purely for the image manifests. That is our Helm charts, or our customize, or our pod.yamls, deploy.yamls, whatever you would like to mention. Okay, so as soon as this GitHub repository is updated with the new image, then the other Kubernetes controller that we have, which is Argo CD, it takes the new image and it deploys on the Kubernetes cluster. So this is our continuous delivery process. So this is how we have set up continuous integration and continuous delivery in our organization, and your interviewer will be impressed with this. So you can follow the diagram that I have shown initially at the start of the video, so that you understand a clear picture. I have drawn it very clearly so that people who look at the diagram, they can easily understand. Let's say you still don't understand, you can go back to the repository. Let me stop sharing so that I can show you one more time. So you can go back to the repository. Let's say people don't know about the repository. I would like to show this one more time, because this repository is very useful irrespective of today's video, we have a lot of Jenkins related stuff in the Git repository. So this is a Git repository where you can refer this Git repository for step-by-step approach of today's video. Okay, so I've explained the prerequisites that are required: Jenkins server, Kubernetes cluster, Helm, Argo CD, and I've explained each and every step, right? So step one is how do you configure the Jenkins plugins. Step two is what type of Jenkins file that you have to write, or Jenkins pipeline that you have to write, what you need to write inside the pipeline, right? What are the unit testing frameworks that you can use, what are the application artifacts that you can do. Then I have explained step by step process about the Jenkins pipeline. The first step would be your Maven, then your unit test, then your SonarQube, then your Kubernetes deployment using Argo CD. Everything is mentioned. Then I have explained you how to set up Argo CD. Then I've explained you how to integrate Jenkins pipeline with Argo CD, right? So all of these things are mentioned. Don't worry, we'll also do a practical of this video. But before we do the practical of this video, it is important to understand the theory part, because no interviewer will ask you to write this entire Jenkins pipeline. It is practically not feasible. Okay, if you end up writing this entire Jenkins pipeline, it will take 2 hours. Your interviewer will be very interested to understand if you can write a Jenkins pipeline. He will just ask you to write a hello world or a very simple Jenkins pipeline. And the important question would be to explain the entire architecture. So that's why focus on the entire architecture. This is very important, rather than you try to write Jenkins file for entire thing, or rather than you try to understand how the Java application looks for this entire thing. That is not important. This is very important. Okay, so I hope you understood the video today. If you haven't understood, definitely ask the questions in the comment section. Try to read this entire document that I have created. Try to understand the diagram. And as soon as you understand this, there is a very good opportunity for you. You can, I don't mind if you copy this diagram. You can copy this diagram and you can put it in your LinkedIn. You can try to write, whatever I've explained today, saying that, you are trying to build a complex, or you are trying to build a ultimate CI/CD pipeline, which tries to integrate the CI process and CD process, where you have used GitOps for the CD process. And you can also mention each and every stage, like I have elaborated here, right? You can try to put this entire thing in your LinkedIn, so that any interviewer who is trying to hire DevOps engineer with strong CI/CD background, they will get notified, or they will continuously try to look into LinkedIn profiles. So yeah, this is the video for today. I hope the video is informative. I hope you found, you understood the entire pieces of the CI/CD pipeline. Thank you so much for watching. Don't forget to subscribe the channel if you haven't. Abhishek.Veeramalla. I'll try to post more and more interesting content. We have also done 45 days of DevOps course. Yeah, thank you so much. I'll see you all in the next video. Take care. Bye.